Hi, my name is Nowak. I'm going to talk about shared libraries in D. Well, the agenda is give a short introduction about the motivation and why you want to use shared libraries. Then I'll talk about some constructs we'll need to add to the runtime library to make better use of shared libraries. And then we'll talk about common use cases and what good patterns are to implement them. And then we have a short discussion about the details. So when you link against a static library, what usually happens is that the linker looks for unresolved symbols in your main file, and it then searches it in a static library, and if it needs any symbols, it copies the whole object into the output executable or in the output shared library. If you contrast that with linking against shared libraries, then the linker will not copy the object file, but instead place a reference to shared library. That comes with some benefits. For example, you can share the disk space. You don't have to copy the object files on this disk. You can share memory if you're having position-independent code. The shared library only needs to be mapped once into the memory, in the actual hardware memory, and you can share it across several processes. So if you think of this like if you have a libc in about every process you have on your computer, there will be a lot of memory if you have to load it every time into memory and have it in actual memory. So it's a huge benefit, but it comes at a cost that it needs position-independent code. If you're having to rewrite the shared library, it doesn't work. Like on Windows, it's very difficult to actually get it working. Another benefit of shared libraries is that you can more easily update your computer programs because you can distribute a new library which has a bug fix, and other programs may use it under the condition that you remain API compatible. It may be also very useful for faster linking. If you have very huge projects of source code, link time might be really an issue. And yeah, it's an option to save some time there. It does come with a runtime overhead. You have to load the shared library. You have to do relocations, which you don't have to do if you do static linking. And position-independent code is not free, but it's not that expensive on modern hardware. Like on x86-64, it's not that expensive. If you use IA32, it's actually very expensive. And the other reason why people tend to avoid shared libraries is they get dependent executables. So you have to set up the library path, you have to get the right version of the shared library. It might break because the API is not compatible any longer. That's an issue. Then there's runtime loading, where your program actually does not contain any reference to a shared library in advance, but it uses a loader to load shared libraries and access the dynamic symbol table of a shared library. So this is a mean to pull out a function pointer of a shared library and actually call into it, and do that on a dynamic basis. So you don't have to know that in advance. You can, I don't know, on a scripting language, you can do it kind of in a scripting language and do it to runtime. And the benefit of that is you can actually load and execute code which is not known at compilation time. So any kind of plugins, any kind of writing text to an editor and then compiling it into a shared library and then loading it, you can do all kinds of stuff like that. And the other benefit is you get an optional dependencies. You might be able to just offer certain functionality in your program if a library is available, and not make the library a dependency of a program. And still the runtime overhead persists. So let's look at the basics. Like one thing I'm going to talk about, I'm not going to talk that much about the technical details of implementing shared library support, but more about runtime loading and how to make use of it in D, because it's more important to talk about this than on the technical details actually. So we do have Windows support for DLLs for quite some time. And we do now, as of now, have support on Linux for linking against shared libraries, because we implemented all that garbage collection and other runtime interfacing. This is what the runtime library supports. It's two functions. Like one is load library, the other one is unload library. And load library returns a void pointer, and unload library takes a void pointer. That's about it. If you use it on Windows, it looks like that. Can you read it, actually? It looks like very small. OK. So you can load the library on Windows. You already have to cast that to an HMod handle. There's some scope exit to unload it. Do I have a pointer here? Yeah. OK, and then you can call get proc address on it. So you can get the address of a function, and then you can call the function if you want to. You have to cast the function. OK. And you can do the same thing with a string function, which is kind of ugly. When we extend the same thing to, if we would extend the same thing to Linux, it would like, or to POSIX, it would look approximately like this. Like, see, you don't have to cast the handle because it's a void pointer anyhow, and you replace get proc address with dlsim, and the mangling is slightly different because Windows does the underscore by itself, and there's a lot of problems with these things. Like the first one, that the platform dependencies obviously totally unnecessary. So the differences could be like abstracted away. Sorry. You have to deal with mangled names. Like mangled names are not for human beings actually, so it's computer talk, it's computer help. It doesn't need to, it's not an interface. I mean, nobody could write down that one on a reliable basis. And then the third problem is that you actually have to cast, the functions to the output point, and there's a redundancy here. You cast that string, function string, and at the same time you have to encode the type here. Because the mangling already contains the type, there's no coupling between these two. And that's very, very unpleasant. So in order to improve here, we'll first think about wrapping the library handle so that we can add some methods and abstract away the platform dependent stuff. So this is just a basic subtyping the library handle, the actual handle, so you can still use it on the operating system functions that you usually have. Like on Linux, there's DLV symbol to load a version symbol, but that doesn't exist on other platforms, so we won't probably support it, but you can still use it on the library handle on any other OS function. And well, okay, there's still load library and unload library, of course, we don't actually need the namespace struct around it any longer, I guess. This is how we can do this. Let's have a look at it. It's load function. It takes a type of a function pointer, and only of a function pointer that's ensured by the constraint. And as an argument to the template function, it takes a fully qualified name. What it does then, it uses another function to construct the mangled name out of it. This is a straightforward function to do, actually, because you can take the mangling of the type and you can just use the fully qualified name. You have to add some underscores and some numbers in it. It's not a very difficult task to do. And then you can use the mangled name to actually query the handle for that symbol. And you can cast that. There's another overload which takes the fully qualified name as template argument, so you can avoid the allocation. So the static is the important point here, kind of. You avoid the allocation of mangle because it's compile time function executable, and might be useful if you know the name of the function in advance. There's going to be another very similar function, which is load symbol. It's not very interesting to actually load data out of shared libraries. It's you can do that. It's only shared and global shared data you can load out of shared library. It's not something I would really recommend because it creates a lot of more problems than calling functions. And the reason why we need a different function for that is because we can't actually specify function types in D any longer. We can only specify function pointer types. So if you want to load a function pointer from a shared library, you're going to need another function, because otherwise that function would confuse the thing. I don't think it's that important to understand. So let's have a look at this again. Like, we do a load library, we enforce that the return value is not null. You can load a function by specifying the type and by specifying a fully qualified name, and you can call it. And you can do the same with a function of a different type, a different name. So what we got here is we no longer have to deal with mangled names, because the mangling is done automatically. That's quite nice, actually, because this is something you could specify, you could easily remember, you could look up in the internet. Okay, the platform differences are gone.
Martin, could you go back a slide or two to that template, the back one, that one, yeah.
Yeah.
On the second template, oh, there, I see it now. I wasn't seeing where the FQN argument was being used. Okay, my mistake.
Okay. It hides the platform differences, which is not that much. And a very important part, it's kind of the type safe. If you use a wrong function type here, like if you add safe to that function type, or if you have a wrong return type, the mangling won't match and you can't load that function. So this is, if you contrast that with the redundant declaration here, this is a huge improvement. But actually, the writer of libfoo might have done a very nice thing and provided a header file. Okay, Like, you get a binary distribution of libfoo, and it comes with a header file, which is like module foo, and then it exports two functions. Okay, so this is actually the caller side. And then you might be able to use these declarations to do all of this. So you avoid another redundancy in that you can automatically use declarations of a header file, which is computer generated by the compiler, and you can distribute it with a file, and on the client side you just have to import this thing and can load a function. And still it's actually type safe, I would say so. And yeah, it's kind of convenient, isn't it? So let's have a look at usage patterns. Like the first one. You have a program and you have different libraries you want to use. The different libraries have all defined their own API, and they come with a header file. The host has to use different APIs for different libraries. And this is approximately how it would look like. The library has to export a module, or it can just define a module and create a header file out of it. And yeah, here's a very short implementation of HTTP GET, and then the host may use that library. It loads it. It might want to check if it's actually available and if the loading succeeds. And there's a scope exit to unload the library later. And it imports the header file to get a function and call it. That's about it. Like, initialization is happening in the load library, and finalization is happening in the unload library. So simple as that. Okay, plugins. The interesting part about plugins here is that, well, that you don't actually have the API on the plugin itself. So somebody that writes a plugin doesn't define the API. The API is defined by the host, and it can do so by exporting a header file. So the host can declare a plugin header file which says which functions have to be implemented and which data has to be defined by the plugin. And then the plugin has to fulfill that interface by actually defining the functions, right? Okay, so what the host can then do, it can actually load any plugin as a library and use the header file to get the interface functions. So the interesting part is here, like one of the problems of doing plugins is, or one of the main points here is that every plugin actually implements the same module. Like in each shared library, you have the same module with the same names, and therefore the host knows in advance where to load the functions and where to get the interface. This is actually very similar to how you would do it in C, like where you have predefined function names for all these interfaces. So in a certain kind resembles the same thing. And well, we don't yet have any opportunity to make use of header files in the implementation itself. So hopefully in the future there will be a link between these two, but it's not currently. So we only get a link between the above and this one. Well, then there's actually going to be introspection, which is quite interesting. For, like, say you load a library and you don't know what it contains, which class it contains. So you can access its module list, like you already do with, like, for each module info, if you've probably done that before. So you can write the name of the module, you can write the name of the local classes, you can access the local classes, you can instantiate them if they have a default constructor. You can look up if they're implementing a certain interface, if they have a base type. All of this is already supported through the module info declaration, so there's not much need to improve here, I guess. Currently, maybe people want to do it, so there's the runtime info stuff you can add. But the basic point is, like, you access you can iterate over all the modules in a certain library. That's the entry point to this. There's also get members, which is, I don't know if it's very known. You can declare a function get members in a module, which returns a void pointer and it's just declared as a void pointer, but it's actually a function. You can declare it in a module and you can use it to define your own interface to query any members. Okay, any questions so far? No? Okay. Yeah?
I'm wondering about the whole dynamic invocation kind of thing. So you want to fetch a class, fetch the methods, or an interface, fetch the methods, and then do some dynamic invocation. And there's got to be somewhere a connection with variant and friends. Is there some thoughts? Do you have some thoughts around that kind of? Like you want to essentially load the library without knowing much about it initially.
Yeah.
Explore it, and ultimately invoke a few functions via like variant, like a complete dynamic interface. Do you think what you have right now is easily adaptable to that kind of?
Well, variant would work, yeah. I mean, variant doesn't support it only supports very basic functionality. Like, it doesn't do templated op binary and stuff like that. But you can actually do that, yeah. You can load a function which you call a variant, and then you can create two variants and operate on them, for sure. So, I mean, one of the key points of getting this right is, like, we have to make libphobos and other libraries also shared libraries, which we already did, and this is the groundwork to get rid of all the one definition rule violations we have on Windows, and to get exception handling right. Like, if you load functions from two different libraries and one throws an exception into the other one, that should work. And this is really groundwork. And if that doesn't work, it's like only bugs. So, and variant is in that kind. It uses type info to query certain information. It just should work. Like, yeah. There's maybe some, as I named the one definition rule, there's one thing here. If you declare this interface, like in a header file, you probably, has anybody written a demos module? Like, yeah, one at least. Great. Like one idea of demos is, like, you don't have to link against them. And not having to link against them is great, but sometimes it doesn't work. Like, if you had an enum with initializer, you probably might need an initializer, and you might need to compile that module into some place. So I said like the plugin, each plugin defines the interface, but there might be some dependency on this being more than a header file. Like, for example, if you want to declare an interface, class or a class, and the plugin and the host should communicate to that class by subclassing. Both your host and your plugin will need to depend on that class definition and on functions defined within that class. That creates a certain problem because you know, like it can't live in the plugin, it can't live in the host. You have to create another shared library which contains the class and that definition, and both the host and the plugin have to link against it. So this is kind of difficult. The only other way would be to export it from the executable itself, which is like totally hack, because then you get a circular dependency. It's like really ugly. So you want to, if you have a very rich interface between a plugin and a host, you will probably need another library for them. We're talking about some details. Well, one detail is that load library initializes only the calling thread. That's one idea of doing it. Windows does a very ugly hack right now, because it if you load a shared library on Windows, then the loading thread actually pretends it walks around all other threads, it iterates over a list of all threads, and then it pretends to be another thread and initializes the library for them, which doesn't work because it creates race conditions. It isn't portable to POSIX. It's not the right solution. And on the other hand, it's also not really efficient. Like if you load a shared library in, I don't know, libfont config or something, it might create a lot of static initialization, and you don't want that for all your other 20 threads which do some computation. So the idea is that it actually only initializes the calling thread, but it comes with a bunch of issues. Like if you use std parallelism, there's a lot of worker threads which don't know the shared library in advance, so you want to actually initialize it, because otherwise if you pass a function to them, then it's most likely to crash. Well, unload library needs to deal with stale objects. Like if you create an object, there's a finalizer to it, and if you unload the library, because the object has no deterministic lifetime, if you unload the library, then the finalizer might get called afterwards. Even, yeah, like on program shutdown, for example. And it's going to crash. And because you don't have any deterministic control about that, because the lifetime is managed by the garbage collector, there are some issues about this. Like one current idea to solve this is to run a collection cycle before you unload the library. But it requires you that you clear all references to any stale objects beforehand. Another approach would be to when you unload the library, to let the garbage collector monitor the memory range, and to only perform the actual unloading when it's no longer referenced, which comes. Well, that's quite an interesting feature for the garbage collector because you also have that for map memory. So when you map a file, so you might also reference, like, I don't know, if you write Alexa or something, then you copy out some slices and you actually want to keep that map memory until the last reference is gone. So I think it's quite useful to have that in garbage collector, but I don't think that it's very nice to do that by default for shared libraries. So there's like people who wouldn't like that. And there's a lot of reasons like false pointers, which would prevent shared libraries from being really unloaded. So you really want to have deterministic control about it. So maybe there's going to be a force unload library and an unload library, which is safe, and the other one which isn't.
I gotta move here, so there's no feedback. Do you think we can integrate unload library with the garbage collector in a way that makes the whole thing safe? Like, essentially during garbage collection time, is it possible that unused libraries are reclaimed?
Yes, yes, it is possible.
Okay,
we need to modify the garbage collector, and it has to support like finalization of memory ranges.
That would be awesome, because it would mean we have a safe solution to essentially dynamically loading and unloading libraries that doesn't impede applications, and it's efficient as well.
Yeah, it's not that expensive actually, because we only have to look at it when after you unloaded it, so like after the last reference is gone. There are probably some issues, but it's doable, definitely. And well, as I said, it's also useful for other kind of map memory where you need to control this. So what's left to be done to get actually there? We have to do quite a lot of refactoring in the runtime still, because the initialization has to be done automatically. You want to have shared libraries being initialized even though C library is loading them. So say you have a C library and it loads a D library, then it should initialize the runtime, it load the runtime and work. And that will require quite some work because it's kind of entangled already. We need to support the dynamic registration and do some work to actually, for all the bookkeeping of the shared libraries, to actually load them, unload them, and doing the thread local storage stuff. And we gotta fix export, kind of, because it works on Windows. It's supported for Windows, or it's a feature for Windows. And actually, I would like to make more use of it on POSIX systems, because the default in POSIX is like you have all symbols visible. If you have a shared library, every symbol that is visible and can be loaded from the outside, which creates quite some problems, because you can accidentally become dependent on a certain ABI, which you didn't explicitly export. Then it creates really huge symbol tables. Like Phobos, for example, had like 7,000 or 80,000 symbols or something, which is quite a lot. It uses a hash table, but still it could be cut down quite. And the most important reason is, if you don't export a symbol, if you don't make it globally visible, the linker can optimize away all of this position independent calling. Like, it doesn't have to be in the programmable linker table, and it can make calls much, much faster if you don't export the symbols. And then there's interposition on POSIX, which is kind of, you probably use that sometimes when you load a library which defines malloc before libc, then you're actually overriding malloc. No. Like there's a global variable ld prebind or something. You can say like, okay. Yeah, okay, LD preload, right? That's the one. And you can use it in all kinds of interposing things to override functions. I don't know what they thought when they implemented that, but it's supposed to be useful. And it doesn't really work because if you want to use that, you cannot really inline exported functions. Otherwise, your inline functions won't match the exported ones. So you really want to have explicit control over export. That's my point of the stance, and we need to fix that. Therefore, because it's only supported for Windows and it has it doesn't name mangling like on Windows. It does import, blah blah blah, and it detects whether something is actually an export or an import by whether it's in declaration or in definition. Like that one would be like DLL import on Windows, and that one would be like a DLL export on Windows because that one is a definition, that one is a declaration. That becomes more difficult with data which is default initialized, so there are some bugs. That's the point. So, well, any huge plugin questions? Thank you.
Regarding that export,
yeah,
transporting the functionality from Windows to Linux, do you see any way to deal with Phobos or the runtime working both as static and as dynamic library when you have to place the export all over the place?
That's an interesting question. I haven't thought about it. If you if you export and you create a static library, then the definitions won't get changed, right? So
the definition
be a problem.
doesn't
but
change,
for
but
the
it's
importing,
always an export for under Windows. It's always an export,
Hmm.
even if it's in a static library. So if it's linked into the executable, you have all the symbols in the DLL.
But it's a problem with the name mangling, right? If you have like a static library, then you don't want that imp prefix on. If you don't,
No, it's this is a problem that the export library is explicitly has to be written or not. You cannot define it away like you usually do in C++ with some preprocessor macro. So you cannot compile the same source code
yeah.
once for export and one for static linking. I'm not sure if there's any good solution. Maybe switch the meaning of the export keyword with some command line switch, but I'm not sure that's a good idea.
Well, we'll see. I mean, another solution would be like, but that's not very nice to use like public and private for that kind of thing, but it's an ABI level, so you don't want to misuse that.
So on Windows, you have to use export, and on Linux or OS X, you don't have to. Do you think we should enforce the Windows behavior on all platforms in D, so we can have something that is more platform agnostic, and we can also open some door for link time optimization or for finalization of virtual function if the class is not override, or this kind of stuff that the compiler can do when it have the old program.
Yeah, that's kind of the idea behind that, right? So, I mean, like, look at if you have a library, like usually, which may contain, like libfont config is a good example. It contains like 20 entry points and probably 1,000 functions. It doesn't make sense to export them all, really. But there's good reasons not to break with the platform default, but on the other hand, like GCC visibility is also something that was only added like in the recent years. So they do have also these. They also have these kind of problems. Like if you load Qt, for example, it exports hundreds of thousands of symbols, and it's a performance issue too.
So my question is actually in the same direction. If I understood you correctly, you're proposing visibility hidden on by default, more or less, right? Like the GCC visibility hidden thing.
Mm-hmm.
So
that's about that, yeah.
Yeah, did you think about like migrating decode there? Because there's quite a bit of decode out there. Which
it's going to take a huge amount of time, of course. Yeah. It's just like if you get export working so that it makes the visibility default, then you can slowly start to make code changes, and
okay.
It's not something you can switch on.
Yeah.
I have another question regarding the module info struct. How do you deal with module info referring to another module info as an import, for example, inside a DLL? Is that this is kind of a data relocation for that?
Maybe I didn't completely like. Can you
say you have an executable that statically links against the shared library, so it's not dynamically loaded, and it contains module info, a module that imports
that imports a module from the shared library.
Yes.
Yeah. Okay.
And that's why you have an import entry in the module struct in the executable.
On POSIX it's definitely a data relocation. Yeah, it's like relocation.
Isn't that the problem with a dynamic, how's it called, a global offset table, that it has to go through it as a relocation, and as it's a data relocation, it has no direct information about the symbol in the shared library.
Well, I think the data it's just a normal data relocation, and when you load the executable, then the runtime linker will go off, search for a symbol, and write that entry.
Okay. Well, I thought the relocations must be only within the image itself, or into the global offset table.
Let's talk
about
this in detail.
Too much details, okay.
It's okay. So, do you have any expectations from plugins? Like, is it anything that isn't met? Like, you going to write a text editor and load some highlighters, something? Would that work?
I'm intrigued by this idea of allowing the garbage collector to unload shared libraries. And it seems to me that some different semantics might be involved. I mean, for example, what if, aren't the only references, isn't it often that the only references to a shared library are function pointers that are in the code, not the data? So, I mean, doesn't the data allocated by functions in the shared library have to belong to the shared library in order for the garbage collector to know that all the data belonging to it, the references are gone, and then it can unload the shared library?
Well, Well, it's usually functions, yeah. It's also data. The point here is like, the point here is if you load a function out of a shared library, you're not supposed to call it any longer. So this is not the issue. The issue comes with the undeterministic lifetime of the objects, which do contain references and are getting called by a garbage collector. So this is what the runtime has to take care of because you can't control it. Like it's not that the garbage collector is intended to prevent you from calling a function in an unloaded library already. This is not the idea behind it.
I think I have to think about this some more.
There may be a point like lazy loading or something, or like a function which is like lazy unload, and then you just do it when you no longer need it. That is a different semantics than what was the idea here.
I'm wondering if you could, when you unload the library, go through all the destructor pointers and find the ones that point to library functions and just nil them out. Then when those pieces of memory go out of scope or whatever,
yeah,
you would just wouldn't call the finalizers of those.
Well,
I suppose you would possibly leave non-GC resources dangling.
I'm not sure I got you. Walter proposed that we actually null out the finalizers so that they don't get called.
Okay, you got two problems. Let's say the DLL creates a instance of a class and hands that to you, and then you unload the library.
Right.
Well, if you call any virtual functions through that class, it will crash because the library code is gone for it. Okay, so implicitly when you unload a library, you shouldn't be holding on to any class objects created by that library. Okay, so that's the first point. And the second point is you do everything correctly. You're not holding any references, but there's that finalizer reference in there. And when the garbage collector eventually gets around to freeing that thing, it tries to call the finalizer. But then the finalizer code will be gone and it will crash even though you as a programmer didn't do anything wrong. In the first case, you did something wrong. You're trying to refer to an object that you unloaded the code for. So I think the correct solution is, since finalizers aren't guaranteed to be run, that when you unload a library, you just run through the unfreed objects in the garbage collector and basically turn off the bit that says I have a finalizer.
Yeah, that was my...
Yeah, that is your suggestion.
Yeah. No,
we talked about this before. I guess we forgot about it. But I think that's the correct solution. It solves the problem rather neatly.
Yeah, it solves the problem. Yeah.
I can't see any other way to do it that works.
All right. Let's give Martin a hand, not only for this talk, but for his great work as well. Thank you. This is awesome. All right. See you again in 5 minutes.
Will bring